Good afternoon, everyone. Thanks for turning out on such a beautiful early spring day. We know this reflects your heartfelt devotion to scientific inquiry, and also that some of you were required to be here, but that's just a small thing. My name is Pat Thomas, and I teach health and medical journalism to graduate students at the Grady College of Journalism and Mass Communication. And this is the fourth year in a row that I've been fortunate enough to be able to co-organize and co-sponsor the Voices from the Vanguard series in collaboration with Dan Colley and the Center for Tropical and Emerging Global Diseases. You know, we have really felt that the purpose of this series was to bring the world to you. I mean, here we are in Athens, Georgia, and we have been able to bring speakers from California, New York, Washington, Boston, even Geneva, Switzerland. But you know, there's a lot of the world that exists in Athens, Georgia as well. And although we've never before featured a UGA professor, this was a first. And as you can imagine, since Dan Colley is the co-organizer of this series, it was really hard to get him to agree to also be a featured speaker, but I'm really glad that he did. And I'm going to now, just one more note I'd like to mention. After Dan's no doubt fabulous talk, we'll be moving next door to Demosthenian Hall, where, as one of my students says, we have the best food of any reception that you find on campus. So come over, talk to the speaker, hang out with us for a little while. That's immediately following the talk. So now I'm just going to welcome another of my favorite people, Vice President for Research David Lee, who's going to introduce our speaker.
Well, I made it up the stairs with no mishap, so that's the good news. I actually had to race back here from Atlanta, had to give a talk at the Board of Regents meeting today. But it was important to me to be here, not just to introduce today's speaker, Dan Colley, although I will do that, but also because I really wanted to have the chance on behalf of the university to thank both Dan and Pat for organizing what I think has been a wonderful series over multiple years now. It's important, this series, not only because it exposes students to some of the cutting-edge work that's going on in the area of global diseases, infectious diseases, but I think maybe more importantly than that, it really has been a great, each of these stories has been a great lesson in what a single individual can do to change the lives of a lot of people around the world, given the vision, given the energy, and so on. And really, as much as anything, that's what I've gotten out of these lectures. And whether that's helping develop or taking the lead in developing a new malaria vaccine, as we heard about most recently, or whether it was starting a foundation that is making a difference in terms of getting people to focus on neglected diseases. I think there have been some really wonderful stories here, and I hope students have been able to enjoy that. I can't think of a more important thing for a university to do than to provide students with those kinds of life examples. Okay, so now I'm going to introduce today's speaker, Dan Colley. Dan is one of these guys who's managed to make a living spending time in some of the greatest places on earth, and I really hate him for that. But maybe that's a consequence of having grown up in Buffalo, New York. I just felt the urge to get away, and in fact, as soon as Dan hit 17, he headed south. First stop was, actually, where was the first stop? Oh, Center College. How could I forget? You have that in common with our president. Dan got his bachelor's degree at Center College, Kentucky, and then headed further south to Tulane, where he obtained a PhD. And I think there, Dan really trained as a fundamental immunologist. He then made a mistake. He headed back north, went to Yale for a postdoc, didn't last 2 years in the bitter cold up in New Haven, decided to make a terrible mistake, and this time he headed south and he didn't know when to stop, so he ended up in Brazil. And there he spent better part of a year and Dan, I may get this story wrong because I haven't had a chance to check it with you, but I think you ended up working with some of the Brazilian federal research entities out in the field, so to speak, working on tropical diseases, and it's there where Dan's lifelong love of schistosomiasis really developed. And as Pat Thomas would point out, there was really a fundamental reinventing of Dan Colley at this point, from fundamental immunologist to immunologist who was really concerned with how to attack a tragic disease that takes a huge toll on a very large number of people. So Dan Colley version 2, as Pat would describe, then came back to the States and ended up at Vanderbilt as an assistant professor, established his research program, got NIH funding, did all the things that a good professor should do, working hard to attack this disease. Somewhere along the way, and I'm not, maybe we'll clarify this afternoon, Dan decided to go to the Centers for Disease Control and Prevention. And he spent 9 years there directing their parasitic diseases group. At that point, he decided that he wanted to come back to the university, to academia. Fortunately, the University of Georgia had a position, and it was to direct the Center for Tropical and Emerging Global Diseases that Rick Tarleton had started a number of years ago. So it's a great story. We're going to hear a lot more about it tonight, and I'm looking forward to hearing Dan's firsthand stories of how he got so interested in schistosomiasis. Dan, it's a pleasure to introduce you.
I'm supposed to put this on. Let me get set up here. Thank you very much, David. Most of that was true. My mother might not recognize some of it, but I'd like to start by thanking the organizers for inviting me. Now, this is a real honor to be able to speak at home. I have no jet lag from doing this. This is really great. So I would like to first start by doing a little advertisement about the Center for Tropical and Emerging Global Diseases, which some of you know about, many of you know about, but some of you don't. And this is the kind of thing that I do at the start of most seminars when I go someplace. What we have here at UGA is a center, an interdisciplinary center that has 19 faculty members, will when Don Harn gets here in March. And the mission is very clear. It's to pursue cutting-edge research on tropical and emerging global diseases and train students in this field. And we have a number of goals. We want to become and remain a preeminent center for research and education in parasitic diseases and other global diseases, and turn research into medical and public health interventions, and to promote global research and education here at UGA and in Georgia. Now, some of those goals are more difficult to attain than others. The middle one is really hard. Turning research into medical and public health interventions is a challenge. It's a long-term goal. But what we do in the center will take us that way, if that's the perspective that we want to put on it. We also have a training mission. We have 5 training grants. One is a standard NIH T32 training grant, and 3 of them are NIH training grants, but they're D43s from the Fogarty International Center to train people in other places, bring them to UGA, train them where they are, let them get their degrees and things in their home countries. And we have 1 in Argentina, 1 in Brazil, and 1 in Kenya. And then we have an Ellison Medical Foundation training grant that is travel. It's to send our students overseas and to bring students from overseas labs to ours. And we have 6 different principal investigators out of the 19 that have overseas research, in-place research. Everyone else has their work here, but these 6 have work here and elsewhere. And this is just a list of the people. And I'm not going to belabor this, but I think it's important to say that it really is interdisciplinary. We have people in the center from 8 different departments, which are listed here, and 4 different colleges and schools. And we come at these diseases from many different perspectives. And I think that's the strength of the center. We don't all collaborate one with another. We collaborate when it's convenient and when there's a need. But we do know that there's somebody down the hall or across campus that we can draw on to get a different perspective on our own research. And I think that's really important. Whoop. So these are the diseases that are studied. We have malaria, African trypanosomiasis or sleeping sickness, toxoplasmosis, cryptosporidiosis, cyclosporiasis, Chagas disease, leishmaniasis, schistosomiasis, lymphatic filariasis, ich, and vector biology. Now, that's a big list of long names. But these are all problems someplace. And many of them are actually still problems in the U.S. Some of them are on the biodefense priority pathogens list. Some of them are major global health problems. Some of them are focal problems. But I'm here to tell you, you don't want any of them. These are not things that you want. So these are the kinds of things that we study. Now, enough of the ad. We're going on to schistosomiasis. So, schistosomiasis, as you could tell by the title, is a worm infection that 200 million people have. That's a lot of people. Now, most of them are in sub-Saharan Africa. Some of them, about 1 million, are in Asia, maybe 2 million, and under 1 million probably in South America by now. So this is largely a sub-Saharan African problem, but not only. The worms actually live in the blood vessels. So we've heard some lectures, and we'll hear some more about soil-transmitted helminths that live in the gut. That's outside the body. Come on, that's not a real worm. These live inside your body, in your blood vessels. And they live there for a very long time. And there's a male and a female, and they mate, and they make eggs, and therein lies most of the problem that we mentioned. The global distribution depends on snails, certain snails. Don't have the snails, you don't have transmission. But it even, to a great extent, depends on sanitation or the lack thereof. And that's the real problem. Someday, we won't have this problem if we have sanitation. It's a chronic infection, so these worms can live in your blood vessels for up to 40 years. 40 years. The mean lifespan is probably more like 7 to 10, but they can live for 40 years in your blood vessels. Untreated, 5, maybe 10% of the people who have it go on to very severe disease and die. And they die of messing up your liver mainly. And the blood flow back through the liver doesn't work, and you end up with esophageal varices, and you bleed out. The other 90 to 95% have what's called subtle morbidity, and we'll mention that in a minute. So there's a good drug for schistosomiasis. It's called praziquantel. It's available. It's not free, like some of the drugs to treat neglected tropical diseases, but some groups are working on that. And praziquantel is a good drug. It cures you. The problem in the real world is people get it again and again and again. There's no vaccine, so we're stuck only with a drug. So this is the life cycle, and it's also the evidence for why I'm a scientist and not an artist. But if you look at this, it's this life cycle. Let's see here. Let's see if I can get the pointer to work. No? Okay. The adult worms, the pink and blue ones up there, the males and females, live in the blood vessels. And they make eggs. And there are 3 main species that infect people, and those eggs are meant to portray those. The eggs have to get out of the body, or there's no life cycle. So the eggs get out of the body in feces or urine, depending on the strain, the species of schistosomes. When they hit the water, They have to get to fresh water. Inside, the little embryo hatches out of the egg and swims around looking for a snail. Not any old snail. It has to be not that snail. A specific kind of snail. Each one has a different set of snails. Then they reproduce in there asexually. So out of one of these Mericidia going into a snail, you might get 10,000 of the next stage. This is the multiplicative stage. So 10,000 of these little wiggly guys come out over here on the left, and they're looking for us. They want to penetrate through our skin. We don't know it. They have a bunch of enzymes that help them get through the skin. They come in, and they migrate around, and over about 5 or 6 weeks, they mature to adult worms, and you have the whole thing all over again. So that's the life cycle, and this is what it looks like in pictures. So you have adult worms up there at the top. They're making eggs over on the right-hand side. What's down below I'll show you in a minute, but the eggs get out, they hatch, the Mericidium goes looking for a snail, turns into 10,000 of the infectious stage, and around you go again. So this is what the adult male and female worms look like. They're not very big. They can't be very big. They're in your blood vessels. So they're maybe about a ½ an inch long and like a piece of thread. And there's the male. Whoops, let's go back here. There's the male. This is technically a flatworm. So this flatworm curves up. The male curves up and forms a groove, and the female fits in that groove, and they sit there in your blood vessels and mate and eat for life. 40 years. Tough life, right? Yeah, stupid worm. Anyway, so the male and the female form this sort of mating pair, and these are just different pictures that either I've taken or stolen from people, and they show the worm out, and they show the worm in the body, and they show that down here in the left-hand corner is the worm in a blood vessel. So you can have a lot of these worms. Most people don't. Up in the left-hand corner is a picture of 1,659 worms that came out of a Brazilian 18-year-old boy, because I counted them, so I know, and a medical student counted them back in 1970. So that's a lot of worms. Most people don't have that many worms, but we don't really know how many most people have. So this is the situation in terms of morbidity and mortality. Morbidity is when you get sick, and mortality is when you die. 200 million people infected in the world. About 20 million of them, remember I said 5 to 10%, so we'll say 10%, have what's considered severe disease. About 100 million have moderate morbidity, or what's these days being called subtle morbidity. Now, I maintain that moderate morbidity is something that someone else has, not you. We don't know how bad this is, but we do know it's not good. And it impedes learning capabilities, it impedes growth, it has, you lose a lot of blood in your urine, things like that. And then maybe as many as 80 million really don't have any consequences, but we don't know how severe those might be. If, maybe there's a gradation there. So this is what the culprit is. So how do you get sick from schistosomiasis? You get sick because some of those eggs that the worm pair makes don't get out of the body. They get swept by the blood to your liver, and they impact in the liver because they're too big to go through the pre-sinusoidal capillaries. So they're stuck in the liver, and your body says, wait a minute, that's not me, that's foreign. Now, why they didn't say that about the worms is a good question, but they say that about the eggs. So your body responds and makes this great big lesion up here called a granuloma around the eggs in your liver. And eventually, in some people, they go on to form what's called periportal fibrosis over in the right-hand picture. Now, what's wrong with that liver? It's not in somebody. Somebody had to die to get that. And they died because schistosomiasis over a long period of time built up a lot of fibrosis around the vessels in your liver, and your blood can't get back up to your heart. So that's the real problem. It's the response of your own body against the products of the worm, the eggs. So this is an ultrasound picture of somebody with just beginning periportal fibrosis. And you can see that the little sort of donut white shapes up there and down below here, and a little bit of banding on the right. That's not so bad, but it will get worse. And it'll end up looking like this, and your whole liver is blocked off in terms of return blood flow. And that's the worst scenario in schisto. There's another kind of schisto that doesn't affect your liver so much, but affects your bladder and your urogenital tract. And if you look at up on the right-hand side, we have a very, very old picture that was taken. It's simply an X-ray. There was no material injected into this person, and yet you can see the outline of the bladder, that big sort of almost circular thing. If your bladder is calcified like that because you have schisto eggs in it, it doesn't contract. Bladders are supposed to go down and up, down and up. This just sits there, which means you have a really bad problem. So the three main species are hematobium, which is what causes this, japonicum and mansoni, and they can cause a lot of trouble. But this is what it really looks like in the field. What you see in the upper left is a young man in Cairo who has hepatosplenic schistosomiasis, the worst form. But what you see on the right lower part is a picture of kids in a village outside of Cairo where the prevalence of schistosomiasis is about 70%, certainly in this age group, except for that jerk over there that got in the picture. But in this age group, it's basically a 70% prevalence. So 70% of those kids have schistosomiasis. And one of them is going to get sick like this kid if we don't treat him. Well, I'm not going to spend any time on this, but I think that it's important to talk about subtle morbidity. There's a guy named Charlie King who's done a number of studies. One of them has really shaken the schisto world, called meta-analyses, where you bring together hundreds and hundreds of papers and try to analyze them all together. And what Charlie did and his colleagues did was to go through all the literature looking for measuring, in this case, hemoglobin in people with schistosomiasis. And what you get out of a meta-analysis is called a forest plot. And if things are on the left-hand side of that vertical line, that's not so good. And what he found was that people with schistosomiasis had significantly less hemoglobin in their blood than did non-infected people. Now, people where they have schistosomiasis have a lot of other things too. So maybe this wasn't all due to schistosomiasis. So the other thing they did is they looked for other papers, and there weren't nearly as many of them, but other papers where they looked at the change in hemoglobin after you treat with praziquantel. And praziquantel only cures schistosomiasis and one or two other worms, but not malaria, not other things that cause hemoglobin loss. And what they found is afterwards you moved things over to the right-hand side of this forest plot, which is good. So they came up with this kind of evidence from a meta-analysis that says that schisto really has perhaps even a broader public health impact than the serious disease. Now, if you have the serious disease and you're going to die, you don't care about the population. But if you're talking about public health, the main impact may be this subtle morbidity, not just the 5% or so that die. So we still have to diagnose schisto by looking in the stool and looking in the urine. But these are the eggs. The one with the sort of funny-looking spine on the side is an S. mansoni egg, and the one with a terminal spine is S. hematobium. So this is kind of messy. This keeps most people out of parasitology. I don't know why it didn't keep me out, but you can make your own conclusions. I did toilet train normally, but this is where you get it. You get it where it's blue and where it's green and where it's yellow. And one interesting sort of side fact from this map is that in the New World, we didn't have schistosomiasis until the slave trade. S. mansoni and S. hematobium both live in Africa. Both came over on the slave trade, but only one of them established in the New World. Only mansoni. There's no hematobium in the New World. Came over with the slaves, didn't last. Why? We don't have that snail. It's snail specific. We have the snails in Brazil and Venezuela and Puerto Rico that can transmit S. mansoni. They just happen to be there. But we don't have the right species to transmit hematobium, so it didn't make it. So, here I am telling you about the snails, and this shows you all the different kinds of snails. Now, isn't that really interesting? However, I have a friend here who said, wait a minute, Colley, this is a disease of snails. Well, Susie Sudanica here is right. This is a disease of snails. They get sick too. So I think it's important that Susie gets her due. So we do have something on here that says this is also a disease of snails. Susie wouldn't let me get by without saying that. So why do you get schistosomiasis? Well, we know why Susie does. It's the same reason we do. Somebody poops in the pond or pees in the pond. Right? You have human, and with one of the species you have animal reservoirs. Water is essential. You have to have water. You have to have fresh water. You have to have fresh water because that's where these snails live. Not this one, but most of these snails. You have to have the right snail hosts. They have to have some place to live. It has to be some place that people defecate or urinate. Adult worms contribute because they make the eggs, and they make the eggs for a very long time. So if you're talking about a chronic infection, you have lots of chances for transmission, and that's important. But it is a very focal disease. So one village may have 60% prevalence, and down the road, 30% or 5%. So it's really hard to map out where you have to go to treat everything. So the transmission dynamics look like this. You have water, you have snails, you have people. You have people contaminating the water and people contacting the water. You have to have both. And when you do, in that little intersection, you get great transmission. It sounds a little tenuous, but I'm here to tell you it works really well in the field. So how would you attack this? Well, sanitation and water and health education. That's a good idea. It probably doesn't work very well if you don't give people alternatives. The sanitation has to be there, or the clean water has to be there. Snail control can work, but the things we poison snails with also kill fish and other stuff, and they wash out, and they're very expensive. Chemotherapy is the current control, and that means drugs, praziquantel. So the current control isn't to stop transmission, it is to stop people being sick. If you give praziquantel about once a year to children in school, they don't get sick from schistosomiasis. Their subtle morbidity is lower, although it's hard to measure that. So we'll come back to the public health control part in a minute. First, we're going to just mention some of the research. So as an immunologist, there are lots of fascinating parts about schistosomiasis, lots. This host-parasite relationship has developed over a very, very long time, and I think it's a large amount of hubris for us to think we're going to just interrupt it. But even if it wasn't a bad disease, which it is, it would be interesting to an immunologist. So what are the major basic biomedical research questions about human schistosomiasis? Well, we'd like to know what correlates and what the mechanisms are to resistance. There is some resistance, and I'll show you a little of that. What are the correlates and mechanisms of subtle morbidity? We're not sure how to measure it. What are the correlates and mechanisms of severe morbidity? Why do 5% get sick and die and everybody else doesn't? We don't know that. Does schistosomiasis prevent autoimmune diseases and atopic allergy? Well, there's some evidence that that's so. Now, does that mean everybody ought to go out and get schistosomiasis? No, it means basic scientists ought to figure out why and then be able to apply it to autoimmune diseases and allergies or transplantation. If that worm that lives for 40 years, if I could do that with a kidney, I'd be rich and famous. How does it stay in there? We don't know that. So asking those sorts of questions in schistosomiasis can shed light in other areas of biomedical research. Okay. So what's our lab's current research? Well, it takes place in Kenya. And we work with a group called sand harvesters and another group called car washers and then children in school. So these are the three groups. The car washers wash cars. Oh, big deal. Down at the car wash. No, in Kisumu, that's Lake Victoria. So they drive the cars into Lake Victoria. In this case, most of them are trucks and vans. They drive them in, and then they slosh them down with water, and they're standing in the water the whole time, which is how you get schistosomiasis. The sand harvesters are even more exposed. They're standing chest deep with a shovel, harvesting sand off the bottom of the lake into their boat, pull the boat over to the shore, empty it out by standing in the lake and shoveling it onto shore, haggle with somebody about the price, and then load the dump truck up. That's harvesting sand. The kids are in school right there, but they're also in the lake much of the time. So Kisumu's in the western part of Kenya. My postdoc and technician, one of my technicians is there right now. I'll be joining them. I'll be there Saturday. Leave Thursday. Takes a long time to get to Kisumu. So these are the people who do most of the research. We also have field teams, large field teams and laboratory teams in Kenya. But here we have Carla Black, Michael Gatlin, and Jen Carter, who are postdoc graduate student technician in the lab. Evan Secor is a collaborator left over from CDC days. And Diana Karanja and Pauline Mwinzi are on site all the time, fortunately, because I'm not. So the epidemiologic question in the beginning was, if we treat this guy, how long does it take before he gets reinfected? And you can only do that by longitudinal studies, which have a whole different feel to them than everything else I'd ever done. And what we found by treating these guys, following them up by doing stool exams about every 4 weeks to see when they got eggs in their stool again. So we did this for years and years. We've been doing this for 14 years out there. Some of these guys have worked with us for 14 years. And in the paper that we published a couple of years ago, now 6 years ago, in Lancet, what we found by following these guys was a little bit surprising to us. We found that the time it took for them to get reinfected differed. We thought everybody might be the same. We hoped they weren't, but they turned out not to be the same. Some got reinfected quickly, some got reinfected more slowly, took more cars, and we call them resistant. And it was exciting because the bottom line here was that when we treated them and retreated them because they got reinfected, retreated them and retreated them, some of them got more and more resistant. And when you do a longitudinal study in basic science areas, what you find may or may not ever repeat itself. So you've worked for 5 or 6 years to get these data, and then you have to do it all over again and see if it works. Well, fortunately for us, it did. And what this slide shows is that some people have to wash a lot of cars, over 450 cars, before they get reinfected. That's the red line at the top. And some people get reinfected after only about 300 cars, and that's the blue line. And the number of reinfections is across the bottom. That's a lot of reinfections and retreatments. But if you do that, some of the people who start out low, slowly but surely become more resistant. And for an immunologist, that's exciting. So it did happen again. We found what we found the first time. And the hypothesis that we work on is that killing worms is what induces resistance. Just having worms doesn't seem to do it. But having dying worms in your blood vessels seems to. At least that's what correlates with the data. Whether that's a mechanism or not, we don't know. So we proposed that on worm death, multiple worm deaths over time, you end up getting more resistant. And we wanted to look at the immune responses that correlate with that. So how do we do this research? Okay. You work with the people. You always have to work with the people. You explain what you're going to do. You've already gotten IRB approval and everything for what you do, but that doesn't get it done. You have to deal with people, and you have to convince them to stick their arm out and give you blood every once in a while, and to give you stool, and you may think, yeah, that's cheap, and it's not so easy. So you have to work with people, get their consent, all of that stuff. Then you diagnose them for schisto, other worms, malaria, and HIV, because they're all common there. And if you don't understand what's going on with those, you don't know what's going on with schistosomiasis. Then you bleed them, take the blood back to the laboratory. So here we are bleeding out by the car wash, and then going back, and we have a regular laboratory with biological safety hoods and all, cabinets and the whole thing. Deal with the blood carefully, because 30% of the car washers have HIV. Deal with the blood, put up cultures, do immunology. That's what you do. Then you get the data from those cultures or whatever you're doing, the phenotyping by flow cytometry or whatever, and then you try to analyze it in relationship to what you know about that patient and what you know about that group of patients. And the more you know about them, epidemiologically and background-wise, the better you're going to be able to interpret your numbers. Because without that, you just got numbers. And then you publish papers and you try to get more funding, and each time you try to improve your question. That's what this is about. So I'm not going to spend any time on the results of that, just that over the last 6 years we've been publishing papers about things that seem to correlate or don't correlate with resistance, and we are still doing so. That's why Carla and Hillary are out there right now, and why Jen is trying to figure out an assay. Did she finish in time to get here? I don't know. Anyway, figure out an assay that I will take out when I go on Thursday. So you get all these correlates. So what? Well, you publish papers, you get grants. Cool. But that's only part of why you're doing this. This is too much trouble to do just for that. So that's a good question. So what? What we hope is to learn enough to form a composite of what is needed to really give you substantial protection against schistosomiasis. Because those are the responses that we would like to engender with a vaccine someday. Just any old, as you heard from Steve Hoffman if you were here in January, just any old response isn't what you want. You want certain immune responses. So we're trying to define what those immune responses are that correlate with protection so that you can go after those responses. And also, immunology, as I said before, is immunology. What we learn here are the same mechanisms that are going on in any immunologic situation, infectious or otherwise. And I think that's a very important point. So the heart of our research in Kenya is, oh, goodness, not that one. Transmission sites. So we have the children, we have the sand harvesters, we have the car washers, and we have the village. This is what the village looks like. Now, we only study villages some, but because you can't control it as well. You don't know the exposure like we do with the car washers and the sand harvesters. But you can see that the women are down washing clothes. This is what they do. That lake has schistosomiasis, and they have the potential of getting it. So, now I'm going to put on a different hat, not as a basic immunologist, not as a basic immunologist doing schistosomiasis, but as a global health researcher and someone that's involved in the other end of what I call the research to control spectrum. Now, this spectrum, we hope it's a spectrum anyway, goes from basic research at the bench all the way to intervention. Or you could say bench to bedside if you're talking medical, but bench to intervention if you're talking public health. And what you have are several levels of what people do to control these kinds of diseases. You have control, which is what we do for schistosomiasis, and we're only controlling morbidity by this annual treatment with praziquantel. You have elimination as a public health problem or in a given area completely. You have, and that's the infections, or you have eradication. Now, we've eradicated smallpox. We haven't yet eradicated guinea worm, but we're close. We haven't yet eradicated polio, and it keeps jumping up and biting us, but we're still working at it. But in parasitic diseases, guinea worm's as close as we get to eradication. Extinction's when it's gone. Smallpox isn't gone. It's in a lab, in a couple of labs, hopefully securely. So what you do, public health-wise, depends a lot on what you want to do, what you have the tools to do, what you have the public will to do. Conceptually, these are very different things, and they often get mixed up, but they're very different. So guinea worm is an eradication program. Onchocerciasis is a control program. Lymphatic filariasis, which you've heard in this series about, is elimination. Schistosomiasis is morbidity control, and that's what we're going to talk about. So a few years ago, the World Health Assembly, which is all the ministers of health from all over the world, sat down in Geneva and decided that they would pass World Health Assembly 5419, which is a resolution on schistosomiasis and soil-transmitted helminths. The burden of disease is huge. For soil-transmitted helminths, it's over 2 billion people. Yeah, I know, it's in 2009, billion doesn't sound like much anymore. We're talking hundreds of billions here and there and everything else. But 2 billion people is still a lot of people. To do these things, you really have to have lots of partners. And that's probably one of the biggest hurdles. But these partners all have to get along, and they don't all have the same goals. Well, they all have the same final answer goals. They don't all have the same reasons for doing it. So it's difficult to put these things, these resolutions, into action. And one of the things that we'll talk about in a minute is operational research, because there's still questions that you have, even though you have an eradication program or an elimination program or a control program, there's still questions that we don't know about that would help that program. So this, about 6 years ago, the Gates Foundation funded something called the Schistosome Control Initiative, or SCI. It operates out of Imperial College in London, and over the years they have had $40 or $50 million. And what they do is they buy praziquantel, they donate that to ministries of health in 6 or 8 countries in sub-Saharan Africa, and they help the Ministry of Health deliver it. They figure out the organizational needs, logistics needs, and they help get it done. And they've facilitated over 50 million treatments with praziquantel in that time. So that's a lot of treatment. And they've dewormed more people for soil-transmitted helminths, which kind of goes along with it, with albendazole. So in the countries listed in the bottom, there are countrywide programs, and they're in place, and they're being shored up by this enormous amount of Gates and now USAID money. And that's a good thing, because we can do it, we should be doing it. There are a lot of people that benefit from this. But the Gates Foundation has also just funded a program here at UGA. It's called the Schistosomiasis Consortium for Operational Research and Evaluation, or SCORE! I left off the exclamation points on the slide. So This is a new program. It's just starting. It's hectically just starting. But it's a consortium to do operational research. Now, that's not basic science. It's operational research. It's defined as finding out what control program managers in the field need to know to do their job better. And their job right now is handing out pills. So part of what SCORE will do will be try to figure out better ways to hand out pills. How do we convince people to take these pills if they don't think they're sick? Well, that's a job. So it'll be run out of UGA, but it will involve investigators from around the world through subawards. So there will be a lot of subawards. And I should mention that the President's Venture Fund here at UGA gave me some money to help me set this consortium in motion before the gates came through, because that was a huge help. Let you travel around and talk to people rather than do everything by email. So, SCORE. There were some ground rules established when the gates called me and asked if I would do this. And they were really pretty firm about their ground rules. Operational research only. No amount of wheeling and dealing with them would let them allow me to study lymphocytes jumping through hoops. This is not what they do. This is operational research, not basic science. We're not supposed to deal with S. japonicum, which is the one in the Far East. I may have some people on my advisory board who deal with S. japonicum, but that's not where the money's going. There's no drug development, no vaccine studies, and we're to work with existing control programs. Well, that makes sense. And we're also supposed to work as broadly as possible with the schisto community, which sounds really good until you try to do it. But anyway, those are the parameters that I was given. Now, all of this is in relationship to Mass Drug Administration, MDA, with praziquantel. So these will be collaborative studies. They will be complementary studies. They'll be done in relationship one to another. So there are three, in the Gates terminology, there are three objectives. Each one has a series of activities below it. The first objective is to evaluate alternative approaches to control schistosomiasis and to eliminate schistosomiasis in settings with lower seasonal transmission. Well, elimination is really, really hard, so we'll see about that. But the activities, the first two activities actually go together, and we'll be having a meeting here with about 25 people from around the world in April to try and get a handle on the existing data. What do we know works or doesn't work in control of schistosomiasis? So these people are going to come together. I sent the letter of invitation out about 2 hours ago. Third week of April, they'll come together for 3 days, and we'll try to sort out what we already know so we don't start trying to reinvent that. The next activity is, how do you sustain control? Okay, the Schistosomiasis Control Initiative did a great job in those 6 countries and brought the prevalence way down. If you leave and come back in 5 years, it'll be right back where it was. We know that. So how do you keep the slope of return as low as possible without spending $10 million every year? So we'll be comparing different delivery systems, and that'll be research, but it's very practical research. The next one will be, how do you achieve real elimination in some place that already has low transmission? I call this the kitchen sink approach. We'll throw everything at it. We will do snail control. We will do latrines. We will do lots of health education, and we'll use drugs, and we'll do everything we can think of. Maybe reroute some waterways, engineering kinds of things. And the next one is even a bigger challenge in that, how do you, for least amount of money, get prevalence low from starting from someplace like that village in outside of Cairo that I showed you that had 70% prevalence? How do you get it down? How do you really get it down? And we'll be doing that in relationship to another series of questions that are a bit more basic science that I'll mention now. Oh yeah, we'll also be doing community health education and cost accounting throughout all of this. So the second objective is to develop the tools needed for a global effort to control and eliminate schistosomiasis. And we have a bunch of activities that are more on the diagnostic side, because we don't have good diagnostics. We're still looking in stools, and it's 2009. Now, come on, we could do better than that. So this money will fund some people to try and do better than that. For diagnostics in snails, yes, Susie Sedanica gets her day too, and in people, because that's one way you can monitor it in the snails. And they're cute too. One of the things that we're going to have a meeting on, even before that bigger meeting, is we're going to have like 5 people from around the world who look at population structures of schistosomes by microsatellites, et cetera. Come together, work out a unified protocol. Yeah, I hear you chuckling. We will work out a unified protocol because that's what we'll fund. And then we'll be able to look at the population structure about which we know nothing at this point under mass drug administration. Mass drug administration, one drug. Does this sound familiar? Sounds bad. Sounds like resistance. So we don't know the mechanism of praziquantel action, so we don't know what to look for resistance. But at least if we have the population structure under study while we're doing mass drug administration, we may see some changes in the genetics of the population that will give us some clues that something's going on. And then we're going to look at subtle morbidity and try to come up with some outcomes that are better than what we have. And the third objective is really simply to try and take this won't kick in until like the 3rd year, where we try to take the findings and actually move them into guidelines at WHO and places like that. So the management structure will be, there will be 3 components. The secretariat, which will be myself, a consultant from Atlanta named Sue Binder, Charlie King, who was the guy who did that meta-analysis, an associate director for management, and an administrative assistant. And then we'll have the technical working group that will meet every year to compare what we're finding, which will be the 15 or 20 PIs of the various subawards. And then we'll have an advisory group, which I'm just now inviting. So how's it going to work? We're going to have these meetings. We're going to select solicitations of proposals to do the protocols that come from those meetings. Those will be awarded, then they have to get out the door, then people will start doing something. We'll have annual meetings to compare what we're getting, and it will be a lot of meetings, but that's what a consortium means. So very quickly, global health and global health research. Do you know these public health workers? They're the best known public health workers in the world. Bono and Bill Gates. Global health has changed enormously over the last 10 years. And a lot of it is because of these 2 guys. And Melinda. Don't leave Melinda Gates out. So Senator Arlen Specter said, when they were looking at the FY 2008 budget, a healthy world is a good thing for America. Health diplomacy must be the foundation of our foreign policy. It's called winning hearts and minds. It's called showing your best side. So the question for the people in the audience, especially the undergraduates, graduate students, and postdocs, how do I get to work in global health? And I'm going to start by saying how Dan Colley got to work in global health. As David pointed out, I went to a high school in Western New York. I went to even a smaller college in Central Kentucky. I married the right woman who would put up with all this stuff when I was there. It was worth the trip, folks, let me tell you. I went to graduate school at Tulane in transplantation immunology and microbiology. They actually had a really good tropical medicine group at Tulane then. And I shunned those people. They were the ones that dealt with those Aki worms and stuff. You know, they had display cases full of horrible looking things. We stayed away from them as much as possible. Then I went up to Yale and did my postdoc in very basic science, very basic. I mean, this was before we knew a lot of stuff. Then I took a kind of a wiggle, and I went to Brazil. I had this opportunity to go to Brazil and teach a course in immunology and reorganize some research that was going on. And the research was in schistosomiasis, and I couldn't spell it. So I went anyway. And I came back to a real job that I rose through the academic ranks, did all those things David said in Nashville. And then I took another wiggle. I'm not really sure why I did this wiggle, but I did. And I went to the CDC. And lo and behold, I was the director of the Division of Parasitic Diseases, not ever having had an epidemiology course or a parasitology course. They didn't ask. It wasn't like I, lied to them on my resume, And then I came here, for which I am very, very grateful. Because it was time to leave CDC. I'd learned a lot and I'd done a lot, and I was real pleased with my time there, but I didn't want to end up there. And so Rick Charlton made a place for me here, and I came, and I've been living happily ever after. So do you see a well thought out path here? When someone comes in my office and wants to know how they can work in global health, they always want me to tell them a pathway. Well, this one skipped around a bit. I don't see a path here. So how do you get to work in public health, in global public health? What kinds of opportunities are there for people like you in public health? I beg you to remember the continuum, that spectrum that I very strongly believe in, but which is really hard to make happen. The spectrum from bench to implementation and intervention is fraught with problems. Not very many people speak the whole language. You don't have to speak the whole language. You just have to be able to speak the one over from you, or at least go out and have a beer with them. Maybe you'll find they're interesting. But remember the continuum, because there are things for people to do all the way along that continuum. Whether they're a health economist or a journalist, even they do global health. They actually do a lot for global health, because without them, nobody hears about it. So you can do global health whether you're a basic scientist or an MD or a public health official or a publicist, the whole continuum. What education and training do you need to work in global health? It depends on which part of that spectrum you want. Now, you may not know which part, so cover your bases. Now, if you want to treat people, if curing people is your important thing, you got to get an MD. It's against the law to do it if you don't. I don't treat people. I have a PhD. I give people pills who give to people, but I don't treat people. Okay? So if treating people is important, you go to medical school. You do your house staff training and become a real physician. Then you do a fellowship, and you do it in anything but maybe infectious diseases, maybe something else, maybe in pediatrics. And then you do that research and things that get you into that. Now, if you want to do research on global health issues, you go to graduate school. You can do research if you go to medical school. There's no reason you can't. But if you go to graduate school, you can't treat people. So you've got to remember those things. But you can go to graduate school in almost anything and end up doing global health. Almost anything. It doesn't have to be immunology like me, although I recommend that either. If you want to set policy, well, you can be an MD, a PhD, have an MPH, have just experience, lots of different things. You can work at WHO, you can work at your local health department. If you want to teach, depends on what level you want to teach. If you want to teach this stuff, fine. We need people to teach this stuff. So how do you want to make your contribution to improving global health? You just need to think about all the different options, and there are a zillion of them. So here in the Center for Tropical and Emerging Global Diseases, we try to turn research into medical and public health interventions. We try to promote global and biomedical research and our educational programs here at UGA. We in CTG are doing global health. And so are a lot of other people at UGA. That's the nice thing about this. That's actually what makes it fun. Takes lots of people with lots of different talents. So, back briefly to schistosomiasis, 200 million people. They can't be wrong. It must be a real problem, and it is. They live in their blood vessels. We can do something for them now. We can give them praziquantum. If we just give them health education, it doesn't help. They know the life cycle in the car wash better than I do. They've been doing this for 14 years, some of them. They know all about schistosomiasis. But they don't have an alternative. They wash cars in the lake because unemployment in adult males in Kisumu is 40%. And they have a job. So they're going to go in that lake. You have to give them alternatives, not just tell them they shouldn't do that. Research is needed, even in eradication programs. If you talk to Don Henderson, the guy who was the head of the global program that got rid of smallpox, he will tell you that during the campaign, there were feed-ins from research that helped them make the final run. We need research. And the research control continuum needs to be real. This means people with many different skills need to work together, go out and have beer together, talk about what you do. Now, I'm going to finish up on a couple of slides that prove that it's not all work. This is where I wrote this talk last week. That's Lake Tahoe. We're at Homewood, one of the ski areas around there. It's really pretty. But this was about 3 days later. It's also really pretty. And you forget, if you're from Buffalo, you should know this, but you forget how quiet it is when it snows. Good to come home from, though. Really, really pretty. Now we're out in Kenya. These are Kenyan elephants and a Tanzanian mountain in the background. These are the kinds of things that you can do on the weekend if you work in Kenya. This is the Mara River. You should not be like wildebeests and cross the river in this lower left-hand corner. It's not a good place to cross the river. Anybody know what the one in the lower right-hand corner is? Got it. Nailed it. Serval cat. Took me lots of trips to Kenya to see that. And we have Kilimanjaro on the left, Mount Kenya on the upper right, the plains of Africa on the left, and then that's the sunset from where I usually stay when I'm there. It's a really tough job, but somebody's got to do it. So that's all, folks. Thank you very much.